So a system is two equations with two unknowns, usually in two variables. And so, and this should be just review. X minus y and 5x minus 3y. I forgot something on the other side. Equals 6 and equals 0. And if you see a little bracket on the side like that, that means it's a system. Okay? And you can solve systems by using substitution method. And I'm going to just use this one set of equations and show you all three ways. Substitution, you know the elimination method, remember that? Elimination. And then graphically. So solving a system means finding where those two equations have a common solution. Okay? So the first thing, let's try this equation by substitution. So to do this by substitution, I want to take one of the equations and plug it into the other equation. So in this case, I need to modify this equation to plug it in. What would I do? How could I rewrite this first equation to get to something where I can plug into this equation? Yeah, add y to both sides. So if I have x minus y equals 0, I could add y. That would be the easiest thing. You could subtract x, but then you have a negative. So if I do that, I get x equals y, which makes this a very easy equation to substitute in. So I could either take x and plug it in here for y, or I could take y and plug it in for x. Let's take y and plug it into the second equation for x. So then I have 5y minus 3y equals 6, 2y equals 3, 6, 2y equals 6, y equals 3. And then you have to find x, right? So to find x, you can plug, oh, what's x? No, not negative, it's just plain old 3, right? Hard? Is that difficult? You've done this, yes? All right, then by elimination, if I had the same system, I just want to do it the same one to show you that the answer always comes out the same. Who can tell me how to solve this particular system by elimination? Multiply one of them. Which one? Yeah, multiply this top one by, what would you want to multiply that top one by? 5 or 3 or negative. I like negative because that way then all you have to do is that, right? So if I multiply this top one by negative 3, then you would get this turns into negative 3x plus 3y. Whoops, I forgot my numbers over here. Okay, equals 6, right? But 3 times 0 is still equals 0. Don't forget you have to multiply both sides, right? So I have to multiply this side by 3 as well, but that's still 0. And over here, this stays the same. 5x minus 3y equals 6. Add them together. This turns into 2x. This turns into 6. You get 2x equals 6, and then you get, but 2x equals 3, sorry. X equals 3. Is that hard? That algebra 1? That's algebra 1, right? Okay. Then graphing, you guys could do these by graphing as well. And so if you want to graph it, you can x minus y. So what is this line? So if I want to graph this first one, what does y equals x look like? Y equals x. Yeah, that's a line that's on the diagonal, okay? And it does go through 0, 0 and has a slope of 1. So this would be the line, this would be equation, if this is equation 1 over here. I would have to change it a little bit before I graph it because it goes through 0, 0, so you don't have, well, the y-intercept is 0. So this is y equals x. And then this other one, you could either do the cover-up method where you plug in like 0 for x, 0 for y, and see what you get out, or you can put this one into slope-intercept form. So if I have 5x minus 3y equals 6. And I subtract 5x from both sides, like that. That gives me negative 3y equals, I'm going to put the minus 5x in front, minus 5x plus 6. Then what? I want to get it in y equals 1. Hello?
Divide by negative.
Divide by negative 3, divide both sides by negative 3. You have to divide everything by negative 3, which turns into y equals positive 5/3 x minus 2, which is a line that has a y-intercept of minus 2 and a slope of up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. Okay, and so if I were to graph this line, let's just pretend that this is it. Let's make it flat. Is that flat? Sure. Okay. And if I go through those points, it's close to I messed up. Okay. And you did this. I could move it. Look at that. Can I move this in? Good enough. All right. So, and if I did this correctly, this should be the point what? 3, 3, which it kind of looks like, but, and you could also solve by graph. A lot of times you solve, the only way to solve a system is with your, well, not the only way. Yeah, a lot of times the only way to solve a system is finding out that point of intersection. So 3 ways to solve the same system, either by substitution, elimination, or graph. Because sometimes, like you will see this, like you'll see something like, we haven't done any e's yet. Have you guys seen e before? We'll do that later on. But if you have something like e to the x equals 3x squared minus 2x or something like that, that's like an impossible, that's like an impossible equation to solve algebraically, really. And so the only way really to solve that is to graph e to the x, which kind of looks like this, and 3x squared minus 2x, which shows something like this, and see where those cross. You know, so sometimes graphing is the only way to solve a system, because like something like this, you can't solve it algebraically, just to show you. Okay, so three equations, 3 unknowns. Then we have, then they like to throw then they like to give you word problems, like this one. Let's grab this one. So a total of $12,000 is invested in 2 funds, and this is kind of classic problem. $12,000 invested in 2 funds, paying 9%, 11% simple interest. The yearly interest is $1,180. How much interest is invested at each rate? Could you do this problem? Yes. How would I set it up? What should I let? You gotta let something equal something. Let x equal what? Read the problem. What are you trying to find? Yeah, so let x equal the amount invested. Amount invested at 9%. And so before you can solve a system, sometimes the hardest thing is setting it up. Let y equal what? Right, amount invested at 11%, and then you need to come up with 2 equations. Huh? So what do you know about x plus y? It's $12,000. Who's got the other equation for me? What's the other equation?
X times 0.09.
Good.
Y times
Nice. Sam. Okay, so 0.09x plus 0.11y equals 1,180. Right? Did I do that right? Okay. Now what? What would be the easiest way to solve this? Well, there's a couple of ways. I don't know. What do you think? Elimination? Maybe substitution. I kind of like elimination for this one. Substitution would work too, but I already did it with elimination, so I'm going to multiply this bottom equation by 2. And not by 2. What should I multiply that bottom equation by? What do you think? Let's get rid of, this is what I did. I multiplied that bottom equation by 10. And then I multiplied that top equation by -9. Why the heck would you do that? Okay? Because then this top equation becomes -9x minus 9y equals minus 9 times that makes something. I did it. 118,000, I believe. Minus 118. Oh!
So
108,000, right?
Yeah.
Okay, I did. Negative 108,000. And when I multiply this equation by 10, I get positive 9x plus 11y equals 100, sorry, 100. Okay? 100 times that, I get 180,000. And then I can add those together. Boom, I get 2y equals, is it 118 minus 10? Is
10,000.
it just 10,000?
Yep.
I think I set up,
It's the same.
oh, I think I started out with it. I started with a different one. It's okay. Equals 10,000, okay? And so y equals 5,000, right? I didn't do anything. What did I do wrong? Oh, that's right, 5,000. And so x would have to be, how many thousand?
7.
Since x was 7,000, okay? Piece of cake, right? And then you could plug into both equations to make sure that works. Like I got this from this equation, but you would want to plug that in there and there to make sure it checks. Okay? Problems? No? Yes. Do you know about solving nonlinear systems? Okay? It gets slightly more complicated because say you want to solving a nonlinear system. So those are both linear systems, but a nonlinear system can have like curves, like circles and parabolas. Systems? I don't know. Systems. So say for instance you have minus 2x plus y equals 5, and x squared plus 3x minus y equals 1, and they say solve. Okay? So this one's slightly more complicated. Who can tell me how I would do that? Sam?
Solve for x on the top and then plug. Solve for y on the top. Plug
Yeah.
for x.
Good. So you want to solve the linear one, right? And the other thing is this is going to make what shape right here? What shape? It's going to make a parabola, right? So I'm not sure what kind of parabola it is. I think it's going to be a right side up one. What shape is this going to make? A line. So either you're going to have two solutions, right? Or could I have one solution? Yes, I could have one solution if it just barely touches that at one, like a tangent line. Could I have no solutions? Sure, if it's going this way. So you could have lots of different things going on. You could have two solutions, you could have one solution, and you could have no solutions. So you gotta be kind of aware of that, and we'll talk about what that looks like algebraically. This one happens to have solutions. Also, like if you have a circle and a parabola, different things can happen. So if you have a circle and a parabola, how many different solutions could I have? I could have 4. Could I have 3? Well, that would be 3, wouldn't it, if it just hit there and there? I could have 4 if I have a parabola that kind of hits it in 4 spots. 1, 2, 3, 4. Could I have one solution? Circle, yeah, I could have one if it just could I have no solutions? Yeah, so there's lots of different, so you got to be kind of aware and look at your answers and see what that means as you go. But in this case, we're just going to solve this for y, so I'm going to go fast. Y equals 5 minus 2x. And I'm going to take that and I'm going to substitute it into here for y, right? And so when I do that, I get x squared plus 3x. Don't forget your parentheses, because you got to use the distributive property equals 1, right? And then, whoops, that should be an x, 3x. And then you want to distribute and simplify x squared plus 3x plus 3x, right? I keep writing 1. 3x minus 5 minus makes plus 2x equals 1. And I want to get everything on the left side because I'm going to end up factoring this, okay? X squared, put together your like terms, plus 5x minus 5 minus 1 makes minus 6 equals 0. And then you solve that either by factoring or some other method for solving quadratics. This one factors to positive 6 and negative 1. Yes? Yep. And so that means that either x equals negative 6 or that's a 1, should be. And or x equals 1. And then you do have to take those and plug those back in to your original. And you get, did I mess up? I don't think I messed up. Did I mess up?
Would be negative 6.
Oh, 3x. Ah! No, I didn't mess up.
No.
Um,
I didn't mess up. And so I'm good. 3x minus 5 minus 2x. I did that right. Because my answer said I must have copied the wrong down. So when x is negative 6, y is 5 minus 2 times negative 6. What's that? 17?
Oh, yeah, it's not negative 2. It's close to it.
Oh, crud. Now I have to do this all. I thought I messed up. Okay. It's okay. Don't. For those of you viewing this at home, that's the first mistake I ever made. Okay. That becomes minus. That becomes 3. That becomes 1x. 1x, right? That's still negative 6. And that becomes, that's what I missed. Okay? We're almost there. That becomes positive 3 minus 2, right? And so then I get x equals negative 3, or x equals 2. And when I take those and I plug them back in, I get y is negative 1, y is negative 1, or y is equal to 9. And those correspond to the points on the graph where y is positive 9. So one place it crosses is at 2, 9. And another place it crosses is at negative 3, 1. Look! I just guessed and I got kind of close to where it actually. Okay, so anyway, that's what you're looking at. Questions? The other thing, if you get something, say you were to solve this thing and you get an answer like x equals plus or minus, say you get x equals, you plug into the quadratic formula, plus or minus 2 plus or minus 2i. What does that mean? What does that mean if you end up solving it algebraically and you get something like that? No solution, okay? That means no solutions. Those lines don't, the curve and the line don't meet anywhere, okay? If you have two lines and you end up getting like 2 equals 5, say you have two lines and you get 2 equals 5, what does that mean? What's that mean? Anyone know? Yeah, because
No
sometimes,
solution?
yeah, it means no, so if you get something like this, you're solving a system of two equations, you get like 2 equals 5, that means no solution. How could you have two lines that don't cross? Parallel, okay? So if you end up getting something like this with two lines, I have 2 equals 5, that means they're parallel, okay? If you solve a quadratic and a linear and you get something like this, that means they don't cross. If you get something like this, like 6 equals 6, do you guys know what that means? Or 7 equals 7, or 0 equals 0 when you're trying to solve, what does that mean? How many? No, it means there's infinite solutions, okay? That means infinite solutions, infinite, and usually that means the same line, okay? Infinite solutions, same line. So when you're solving systems and you get something that doesn't make sense, you should know, okay, this means I have infinite solutions. I'm really talking about one line disguised as the other line. If you have this, I'm talking about two lines that have the same slope but are parallel. And if I get something like this when I'm solving a quadratic or something like that, it means they don't ever meet. All right. Good. What else? One more thing, and then I'll be done. Yay! How much time we got in this place? 10:50. This is period 3. 10:57. So I like this problem. If I could find it. Headwind problem. Maybe I could take a picture of it. Maybe I could. Here, I'm going to do this. I'm going to make a new page. Oh, I didn't copy it. Did I do that? Edit? 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 No. That's someone. Oh, maybe I did copy it. Okay. Edit, edit, paste. What the heck? Oh wait, that's from my geometry stuff. Where'd that come from? Let's try again. I'm getting better with the Mobi board. I still don't have complete mastery though. Where's the copy?
You need to select it.
I need to select it. Get this. Go like this. Right? Oh, there we go. Edit. Copy. New thing. Edit. Edit. Paste. Come on, buddy. Good enough. Alright. Just ignore this. Go away. What's that? Go somewhere, please. I don't know. Edit. 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 Cut. There. Okay. So now that you can't see that because I should have pointed. So this is one of my kind of favorite kind of problems. You've probably seen problems like this. An airplane flying into headwind travels 1,650 miles, flying a distance between two cities in 3 hours and 18 minutes. On the return flight, the distance is traveled in 3 hours. Find the airspeed and the plane speed of the wind, assuming that both remain constant. Would you guys know how to do that? Yes, some of you would. Some of you would. Okay, so now it's with a problem like this, you want to set up a variable. So I would just let A equal the airspeed. A equal airspeed of the plane, because that's what you're trying to find the airspeed of the plane, and let W it used to be present. Let W be the wind speed. Wind speed. And you also know that, you guys know that rate times time equals distance? Rate times distance doesn't equal time, does it? Okay? I should write before I speak. Rate times time equals distance. So this is the relationship you're going to use. So if I'm flying into a headwind, it travels this distance and it takes me 3 hours and 18 minutes. So the way I set that up is the airspeed minus the wind speed. And this is kind of an ideal environment in which the headwind is exactly kind of slowing you down the exact amount that it's blowing, which isn't really the case, you know, it doesn't, but this is kind of idealized. So A minus W times the time is equal to 1650. Okay? Oops, and we know the time, don't we? Okay, which is, and you should write it as 3 hours, 3 and 18/60 hours. Oh, that looks complicated. Equals 1650, because you got to keep the units consistent. And then, going with the wind, A plus W equals, or times 3, is also equal to 1650. Right? And so now you solve this system. Well, the easiest way to do it, what you want to do is divide this by 3 and divide this by this. Okay? Which can get a little ugly, but not too ugly. So if you divide, so I'm going to take this, so here's the system that you want to solve. Any questions on where that system came from? Okay, so E, what's wrong?
No, sorry.
Yes.
That's right. So, so what I would do is take this first equation and divide it by 3. Okay? And that gives you A plus W equals a nice even, is that 550? No, that's not right. A plus W.
550 is.
It is 550. I knew that. 550. And then what I need to do, you gotta kind of be kind of algebraic, kind of smart, but this is 180 plus, so that's 198 60ths, right? Yes? This number right here? So I'm going to change this to 19, yeah, these numbers come out nice. So I want to get rid of this here, so I'm going to multiply both sides by 60 over 198. 60 over 198. I'm going to multiply this by 60 over 198. And this is kind of a nice problem because it works out. A minus W equals, is that 500? Is that, okay. And then you can solve this system by elimination by adding them together. So you get 2A, that goes away, equals 2A, that's not a 9. 2A equals 1050. So the airspeed of the plane is equal to 525. And that means that the wind speed must be what? If A minus W is 500, what's W? Oh, 25. And make sure it checks over here. Is A plus W 550? Go like this. Okay. Yes. Okay. So that's it. So that's, I mean, you have a couple different types of word problems. There's, so in your homework, there's a bunch of different ways of solving systems, and then I gave you one of each of these types of word problems. Yes, sir.
What's A minus W?
Yeah, so if you're flying this way, right, and the wind is pushing you backwards at a rate, so the wind's pushing you at 25 and you're trying to go 500, right? 525. And your net speed is kind of like adding vectors, right?
So it's A minus W, right?
Yeah, that's A minus W.
How do you get A plus W?
Because that's when the wind is pushing you, right? So you're adding those two vectors. So this, he's trying to go this way 525, and the wind is pushing him 25. Now, in an ideal situation, that doesn't really happen, because you don't, like if you're driving down the road and or in a plane, I don't think, I'm not really a pilot, but if you're going like 200 miles an hour in a plane and you have a 50-mile-an-hour tailwind, I don't think you, maybe you do, go 250 miles an hour. In a boat, like if it's a current problem, right? And your boat could go 20 miles an hour, and the current's going 10 miles an hour, and then you're actually going. I used to, I should pause when I tell you my stories. Okay?